In this clip, we're going to take a look at what happens when we have an amortized loan, or in other words, one with equal payments at a positive interest rate. So we'll try 10%. So first what we'll do is we'll go from our balloon loan that we created last time, right click on that, make a copy of the sheet, move it to the end, rename this, amortized loan, and the inputs would be similar as we did in the past. We'd have, say, a $10,000 loan, 4 years, 1 annual payment, and we'll make it 10%. The number of payments is again a formula. It equals B2 times B3. In other words, the years times the payments per year. The periodic payment, that's going to change. So for right now, I'm just going to put in a number, $2,500. And I'll just hard code that number in. The total paid is the number of payments times the periodic payment, so E2 times E1. And then the total interest is the difference between the total paid, cell E3, and the amount that we borrowed in the first place, cell B1. At payment 0, in other words, right now, right when you take out your loan, the payment amount is 0, the interest is 0, the principal is 0, and the balance is equal to the amount that we borrowed. Now when we take out our first payment, what I'm going to do is I'm going to reference this periodic payment in cell E2. Now I'm going to want to copy this down to cell B9, B10, B11. So if I just take that cell and copy it down, I don't get the right results because it's using a relative cell address. In other words, when I copied this down, it's saying, give me the contents of the cell that's 1, 2, 3 to the right, 1, 2, 3, 4, 5, 6 up above it. So when it's copied down here to cell B9, it's 1, 2, 3 to the right, just as before, and 1, 2, 3, 4, 5, and 6 up above in that relative position. So that's not correct. So what I need to do with this E2, instead of letting it change to E3, E4, and E5, I always want to reference cell E2. So I need a $ in front of the 2 so it locks in that row 2. I could put it in front of the E, but we don't want to get in the habit of doing that because I'm copying this straight down. The column's not going to change in this case. So we'll make it E $2, copy that down, and there's my equal payments. Alright, for the interest, notice that the interest is changing. So here's what's happening. I'm just going to delete out the interest for now to show you how we set this up. The interest is equal to the balance that we have on our loan, $10,000. And I'm going to multiply that by my interest rate. The annual interest rate is 10%. And when I copy this down, I'm going to want that B4 always to remain B4, so I'll put a $ in front of the 4. And I'm going to divide that by the payments per year, cell E1, I'm sorry, B1, B3, sorry about that. And again, use a $ between the B and the 3 because we're going to copy this down. I always want to remain row 3. Type in my right parenthesis, hit enter, and I get $10,000. In other words, 10% of $10,000. The principal is equal to the periodic or the payment amount minus the interest rate. So that was $1,500. So it's that $1,500 that we reduce from the balance. So my balance is $10,000 minus the $1,500, so $8,500. It'd be the same kind of thing for the next payment. The interest rate is going to equal my balance, $8,500, times 10%, so that's $850. When we divide it by 1, it's still the same amount. And there's $850. So I'm actually on this check that we write out for $2,500, we're paying more principal, $2,500 minus $850, and that reduces my balance by even more. So the next payment that we'd have, $2,500, we'd pay 10% on $6,850, so that'd be $685. My last one's going to be $435. So we're going to copy this down, and you can see slowly my interest is decreasing and slowly I'm paying off the loan. The only problem is if we make just a $2,500 payment, that was the payment that we'd have to make for a 0% loan. So if I change my rate to 0, it works out fine. But as soon as I increase the rate, say make it 5%, well then I'm not paying off my loan all the way. I have to increase my periodic payment. So let's set this at 10 and start playing the what if game of how much do we have to change this periodic payment to make it pay off my loan. Well, if we think a little bit about it, if we go back to the balloon loan, there the balloon loan was equal to just the $10,000 times the 10% divided by one payment per year. All right, it was just $1,000 each time. But then the total paid ended up being equal to the number of payments times the periodic payment plus the original amount that I borrowed from the bank. So I know that my periodic payment has got to be something greater than $2,500. So let's just take a guess and say, what if we tried $3,000? And when I plug in $3,000, my balance is still a positive number, $718. So it's got to be more than $3,000. Let's try $4,000. If I pay $4,000 every payment, you can see that we end up overpaying on it because I've got a negative balance, which means the bank kind of owes us money back. So it's probably going to be closer to $3,000 than it is $4,000. So we'll try $3,200. And at $3,200, I'm still overpaying. So it's between $3,000 and $3,200. Let's try $3,100. Split the difference. There I've underpaid. So let's try $3,150. I'm still underpaying a little bit. $3,160. There we're overpaying. $3,155. And we're just about there. $1.36. So that's kind of the hard-coded method to solving this problem. Well, there's two better ways of solving it. The first way that we can do it is if we go to Data, Excel has a what-if analysis tool. And they've got a tool that's called Goal Seek. So what I'm going to do with Goal Seek is I want to set the balance to 0. And I'm going to change the cell where I've got my periodic payment. Hit OK. It finds a solution, and it turns out that it actually was really close to $3,155. And in fact, if we increase the decimal here a couple of times, it's $3,154.71. And if you look up in the formula bar, you can see actually it's carried out to a whole bunch of decimal places. So you could argue that really if you were writing checks out, the bank isn't going to take checks for fractions of cents. So we really should make it $3,154.71, and we end up overpaying by a penny, and the bank would adjust it on that last payment that we make. So that's option number 1. So we'll say solution 1, use data tools, Goal Seek. And we'll check and make sure that that's what yep. So it's data, the group is the data tools group, what if analysis, Goal Seek. So we'll plug that in here. The second solution is to use the payment function. There's a built-in function for this because it's a popular function. We're going to click on the FX key, and I want to take a look at and search for a loan payment function. And it finds this function that's called PMT that'll calculate the payment for a loan based on constant payments and a constant interest rate, which is what we have. And we plug in the arguments. So the first thing is the rate. It says the rate's the interest rate for the period of the loan. For example, use 6% divided by 4 for quarterly payments at 6% APR, annual percentage rate. So our annual percentage rate is 10%. We're going to divide that by the payments per year. The next function is N period, the total number of payments for the loan. Total number of payments for the loan is found in cell E1. In other words, it's the years times the payment per year. The PV is the present value. It's the total amount that the series of future payments is worth right now. Well, that's basically what we're borrowing. So I'm going to reference cell B1. Now when I do that, notice the result is a negative 3150 70.8037, or rounded off 3171. That's what we found before. However, I don't want this to show as a negative number. So what I'm going to do is I'm going to type in front of my B1, I'm going to make that present value a negative amount. So in other words, it's kind of like we're borrowing the money. So if I make it that negative, it basically multiplies my payment by -1. It becomes a positive number. We hit enter or OK, and sure enough, there's our balance at and ended up being 0. So this is really the best solution, because that way if I change my rate to 6%, it recalculates this and finds the correct periodic payment, and I get a 0 balance. So pretty much whatever interest rate we plug in here, it will work. For whatever loan amount we plug in, $20,000, it recalculates this. So the payment function is the way to do it. So let's change one more thing. Let's make this 12 payments per year, which would be more likely a standard car payment. And I need to insert some rows. So I've got 4 payments so far. If I've got 4 years at 12 payments per year, that's a total of 48. So I need to put in 44 more rows on my amortization table. So there's 1, 2, 3, 4, 5. And you can see if you look down here to the left, it tells you how many rows you've selected. I need to go down to 44. Right click on any one of these rows. Choose Insert. Take my payments, copy them down, all the way down to the bottom. Leave it one blank row above. Oh, hang on, I gotta try that again. I need one blank row above my totals. And then I'm gonna press enter to copy that. And there we go. We've got a 0 balance after 48 payments. The total amount paid is $22,988. I'm gonna increase a couple of decimals there. The total interest, $29,839. So we'll insert a couple extra decimals there. The total principal matches what we borrowed in the first place. Everything looks pretty good. So I'm going to leave this down so you can kind of see the effect of freeze panes. See our grand totals at the bottom. That looks pretty good. One other thing that you might consider doing is you might want to throw a graph on here. So if I highlight the interest and principal, let's move this chart and we'll call it the amortized chart. And there you can see what happens as we go along. The principal starts increasing slightly, the interest rate falls down. So if you don't like using a column chart, you can change the chart type. You might try a stacked column, which kind of gives you interest rate results. Here the top of the bar basically tells you what your payment is, and you can see how much of it is going towards interest versus how much is going towards principal. You know, it's not too bad of a chart to do that. And we'll just say that this is the amortized loan. Or if you want to do a line chart's not a bad way to do it. Surface charts work out as well. So we'll take our chart, move that to the end. There's my amortized loan. We'll save our file, and we've pretty well got that set.